Hello students, today we are going to study about graphs of trigonometric functions. All trigonometric functions are periodic. For example, sine and cosine functions are periodic with period 2 pi, while tangent and cotangent functions are periodic with period pi. If the graph of a periodic function with period t is to be drawn in a given interval, then it is sufficient to draw the graph only in an interval of length t, because once it is drawn in one such interval, it can easily be drawn completely by repeating it over the intervals of length t. For example, let y is equal to sin x, it is defined for all x belonging to R. As the period of sin x is 2 pi, it is sufficient to draw the graph in the interval 0 to 2 pi and then complete it by repeating over other intervals. The amplitude of a function is defined as the greatest numerical value which it can attain. So, by using this discussion, we shall now draw the graphs of various trigonometric functions. Now, let us first take up the graph of function y is equal to sin x. Since sin x is an periodic function with period 2 pi, so we will draw the graph of y is equal to sin x in the interval 0 to 2 pi. For this, we first draw it in the interval 0 to pi by 2. The values of sin x for different values of x in the interval are given in the following table. The values of sin x for different values of x in the interval 0 to pi by 2 are as follows. Sin 0 degrees is 0, sin 30 is 1 upon 2, that is 0.5, sin 45 is 1 upon root 2, which can be simplified as 0.707, sin 60 is root 3 upon 2, which on simplification gives us 0.866, and sin 90 is 1. Using the above table and the fact that sin x is an increasing function, we obtain the graph of y is equal to sin x in the interval 0 to pi by 2. Then, in the interval pi by 2 to pi, we draw the graph of y is equal to sin x by using the fact that sin of pi minus x is equal to sin x. Finally, we draw it in the interval pi to 2 pi using the fact that sin of pi plus x is equal to minus sin x, which means that the graph of y is equal to sin x in the interval pi to 2 pi is the mirror image of the graph of y is equal to sin x in the interval 0 to pi. Let us see how the graph of the function y is equal to sin x looks like. This is the x axis x dash o x, and this is y axis y o y dash. We begin with origin, and as it is an increasing function, we can see that the graph is going between 0 to 1 and then it is coming to pi, and same way we can plot the graph from pi to 2 pi. This is the graph of y is equal to sin x. So, students, let us pick up one more example to see how we can sketch the graph of the function y is equal to 3 sin 2 x. To obtain the graph of y is equal to 3 sin 2 x, we first draw the graph of function y is equal to sin x in the interval 0 to 2 pi, and then divide the x coordinates of the points where it crosses the x axis by 2. This is the way we can draw the graph of the function y is equal to 3 sin 2 x. We can see x dash o x is the x axis here, y o y dash is the y axis, and we can see that the graph is an increasing function. It goes from 0 to 3 and then it decreases and it reaches pi by 2 here, and similar manner we can do it till pi. This is the graph of y is equal to 3 sin 2 x. Now, let us take up graph of the function y is equal to cos x. Since cos x is a periodic function with period 2 pi, so it is sufficient to draw the graph in the interval 0 to 2 pi. For this, we first draw the graph in the interval 0 to pi by 2, and we use the fact that cos x is a decreasing function in this interval, and the table with values cos 0 is 1, cos 30 degrees is root 3 upon 2, cos 45 degrees is 1 upon root 2, cos 60 degrees is 1 upon 2, and cos 90 degrees is 0. Now, to draw the graph of the function y is equal to cos x in the interval pi by 2 to pi, we use the relation cos of pi minus x is equal to minus cos x. If we give values between 0 to pi by 2, then this relation shows that the values of cos x between pi by 2 and pi are negative for its value in the interval 0 to pi by 2. Thus, the graph of y is equal to cos x between pi by 2 and pi is below x axis. Now, cos of pi plus x is equal to minus of cos x shows that the graph of y is equal to cos x between pi and 2 pi is the mirror image in x axis of its graph between 0 to pi. Look here, we have x axis x dash o x and y axis y o y dash, and we can observe here 0 1 is the point and it is decreasing function, therefore, it comes down to pi by 2, and here we can see it is completing its graph till pi. This is the mirror image of the previous graph. So, y is equal to cos x can be plotted in this manner. Let us see how the graph of the function y is equal to tan x looks like. Since tan x is a periodic function with period pi, so it is sufficient to draw the graph over an interval of length pi, in particular between minus pi by 2 and pi by 2. First, we will draw the graph in the interval 0 to pi by 2. For this, we use the table as shown on your screen and the fact that tan x is increasing in this interval. We find here tan 0 is 0 and tan 30 is 1 upon root 3, tan 45 is 1, tan 60 is root 3 and tan 90 is infinity. Also, as x tends to pi by 2, tan x tends to infinity. So, the graph gets closer and closer to the line x is equal to pi by 2 as x tends to pi by 2, but remember it never touches the line x is equal to pi by 2. Since tan of minus x is equal to minus tan x, therefore, if x tan x is any point on the curve y is equal to tan x, then minus x minus tan x will also be a point on it. This means that the graph is symmetric in opposite quadrants. Let us see how the graph of the function y is equal to tan x looks like. X dash o x is the x axis, y o y dash is the y axis, and we can see that the graph is increasing from 0 to pi by 2, but it is not touching the line pi by 2. We have in the similar manner between pi by 2 and pi, pi and 3 pi by 2. Similarly, here between minus pi by 2 and pi, we can see the graph is increasing and going along with pi by 2, but it is not touching the line pi by 2. Here it is decreasing along the line for minus 3 pi by 2, again not touching the line pi by 2. It should be noted that cosec x and sec x are also periodic functions with period 2 pi, while cot x is periodic with period pi. As x tends to plus or minus pi by 2, sec x tends to infinity. So, the curve comes closer and closer to infinity as x tends to plus or minus pi upon 2. The graph of the function y is equal to sec x can be drawn in this manner with x dash o x as x axis, y o y dash as y axis. We can observe how the graph is decreasing and increasing between 0 to pi by 2. Similarly, the graph between minus 3 pi by 2 and minus pi by 2, we can see how it appears, and here between pi by 2 and 3 pi by 2, it can be seen in a similar manner. It is the just mirror image of the previous graph. Now, we will draw the graph of the function y is equal to cosec x. You can see the graph of the function y is equal to cosec x on your screen. X dash o and x is the x axis. Similarly, y o y dash being the y axis, we can draw the graph of the curve y is equal to cosec x between 0 and pi in this manner, and between origin and minus pi in this manner, and between pi and 2 pi again as mirror image of the graph between origin and minus pi. Now, let us see how the graph of the function y is equal to cot x looks like. X dash o x being the x axis, y o y dash being the y axis, and we have intervals here 0 to minus pi by 2, minus pi on the left hand side, and pi by 2 and pi on the right hand. And we can see how the graph is just going to touch pi by 2, but it is not touching the line pi. So, students, today we learned how to plot the graph of various trigonometric functions like sin x, cos x, tan x, cosec x, sec x and cot x. In the next session, we shall study about trigonometric functions of sum and difference of two angles.